Alright, till now we have learned what's a tree and why do we need a tree data structure. And we have created a simple tree using Java programming language. Now in this video, let's learn first type of tree, which is a binary tree. So what's a binary tree? In the previous lecture, when we have created basic tree structure, we saw that we can add unlimited children for one node over there. But in case of binary tree, it's different. Binary trees are the data structures in which each node has at most two children, offered as left and right children. It means that any node in a binary tree cannot have more than two children. The maximum number of children in a node is 2. The basic structure of binary tree is look like this. Here you can see that each node has maximum number of 2 children. It might have one child, but it's not possible to have more than 2 children in a one node in this case. Now if we examine this tree over here, we can see that N1 has 2 children, N2 and N3. N3 has 1 children, which is N6, and N2 has 2 children, N4 and N5, and N4 has 2 children, N7 and N8. And here you can see that we don't have any node that in which we have, for example, 3 or 4 children. So the maximum number of children in this case, in case of binary tree, is 2. So this is the main property of binary tree. Now the second property of binary tree is that it's a family of data structure. Now what do you mean by that? It means that all of these trees, like binary search tree, heap tree, AVL tree, red-black trees, and syntax trees, are all binary trees. Their basic property is driven from binary tree. And these trees that are mentioned over here are all binary tree. And here, all of them follow the basic property of binary tree, which says that a binary tree can have at most 2 children in one node. So hopefully everything is clear about binary trees. Now let's see why do we need binary trees. Now the first reason is that binary trees are prerequisites for more advanced trees like binary search tree, AVL tree, and red-black trees. So without learning a binary tree, it's extremely difficult to learn these three data structures over here, which are more advanced tree data structure. Moreover, there are some specific problems that can be solved using specific techniques. Huffman coding problem, heap priority problem, expression parsing problems can be solved efficiently using binary trees. So without binary tree, these problems becomes extremely very difficult in computer science. So these are the reasons that we need binary tree. Now from the next lecture, we are going to learn different types of binary tree and we are going to implement binary tree in practice. So hopefully everything is clear about this lecture. So in this lecture, we have learned what's a binary tree and we have learned main properties of binary trees. And finally, we have learned why it's very crucial in computer science. Now with this, we have come to the end of this lecture. So hopefully everything is clear about this lecture. Now in the next lecture, we are going to learn different types of binary tree. So see you in the next lecture.